Welcome to this video on simplifying radicals. First, let's talk about what is a radical. The actual radical symbol is a radical. The number that goes underneath the radical is called the radicand. And sometimes there is a number that sits on the radical shelf out here, and that is called the index. Usually, you'll see there could be like a 3 sitting there, or a 4, or sometimes you just see it with just the radical sign. If there is no index sitting out there, then we assume that number to be 2, and we'll be talking about square roots, which is what we're going to limit our notes to today. All right, so perfect squares. I want to review real quick with you some perfect squares so you know to recognize them when you see them when we start breaking these numbers down. So remember, a perfect square is something times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Okay, and then we'll keep going. We have 16, 25, 36, 81, nope, sorry, we had 49 in there, 64, 81, 100, 121, 144, that's to 12 square. Let's go ahead up to 15, 12, so 13 is 169, 14 squared is 196, and 15 squared is 225. The reason we do that is just to kind of bring it to the front of our thinking in case we see one of these perfect squares, because if we see a perfect square, we know a radical might go away. Okay, so if I asked you what is the square root of 16, you would tell me 4. Most of you right off the top of your head without even thinking. But why? All right, so here is why. Our index here is 2. Whatever the number of the index is tells you how many of the same number you have to have for them to kind of come together and bring one out. So what I mean by that is 16 is 4 times 4. I have 2 of the same numbers. That means they become just one number and it comes out. The square root of 16 is 4. Sometimes there's already something on the outside of our radical. So how do we handle that? Well, 121, we just said 121 was 11 times 11. So we have 2 of the same number, which is what our index wants. When we have 2 of the same number, they kind of come together and one will come out. So we have an 11 on the outside of the radical, but we also had this 2 that's got to come on over. And we will multiply those together. 2 times 11, 22. Let's try this with number 3. 289 wasn't on our list, so here's how we'll check this out. Take your handy dandy calculator. And we want to make a square root sign. So you're going to do the second button right here. It's usually blue. Second, and then down here to x squared, and it will give you a radical sign. And we have 289. And when I press enter, it tells me 17. The square root of 289 is 17. Because 289 is 17 times 17. All right, so we have 2 of the same numbers. That means one's going to come out, but we had the 6 that was already here. So 6 times 17, let's use our handy dandy calculator again. 6 times 17 is 102. So what we're doing is we're writing the equivalent form. 6 square root 289 is 102. 6 second x squared 289 equals 102. Okay, so you're just rewriting it in a different form. 400, if you're not sure what will make up 400 with perfect square, second x squared 400 is 20, because this is 20 times 20. You have 2 of the same number, so 1 will come out. And there's no other numbers left behind. So your radical drops away, and we still had the 3 in front. 3 times 20 is 60. Right, well, what if they're not perfect squares? Because, of course, most of the questions we'll ask you are not perfect squares. How do we deal with this? So let's just try some of these. One, you could see if there is a perfect square that could make up your radicand, then you can take your square root and whatever's left over goes back under the radical symbol. So 32. I could get to 32 by rewriting it as 2 times 16. You just want to start breaking these down. I rewrote 32, so I'm going to ignore that 32 up there. 16 could be written as 4 times 4. And remember, we were looking for pairs of the same number. I have a pair of the same number. What does that mean? That means they kind of join together, and the 4 is going to come outside of the radical. It's done being under the radical. Okay, but this 2 does not have a pair, and it will not break down any further. That means the 2 is left over, and it's going to stay under the radical. 4 square root 2. So if I check my calculator, second x squared, the square root of 32 is this irrational number. Remember, we had the video talking about rational and irrational numbers. Let's take a look. If I put in 4 second x squared 2, I get the same irrational number because these two things are equivalent to each other. All right, the radical, when it's simplified, didn't go away, so this is irrational. Let's try 180. Really, you're looking for two numbers that multiply together to start breaking this down, and you'll start looking for pairs. 180, well, I see right away 18 and 10. All right, and then just keep breaking them down. How else can I break down 10? We're trying to get to some pairs. 10 can become 2 times 5. All right. And I can't break either one of these down any further because this is a prime number and this is a prime number. But 18 will break down again. How about if I did 2 times 9? I like to cross these off when I rewrite them so I don't think that's a number I still have to deal with. 2 will not break down any further, but 9 will break down one more time to 3 times 3. Okay, now let's look at all these numbers that I've got. I've got a pair of 3s. That means I'm going to have a 3 come to the outside of the radical. I have 2 2s. They don't have to be side by side. 2 and 2. That means one of them is going to come out. Remember, whatever comes out multiplies to what's there. And then I have this 5 with no pair. That means he's going to go back underneath my radical. So on the outside, I have 2 times 3, which is 6, and a square root of 5 on the inside. You can double check yourself. So we had the square root of 180, which is this irrational number 13.416. Okay, let's look 6 square root 5, same exact number. We know we broke it down properly. Okay, we can just double check. But I'm not wanting the decimal answers for these. I want this, which is called simplest radical form. All right, 147. Well, I know it's not divisible by 2 because it's not even. A trick for 3s, if I add these up, I get 12, and that's divisible by 3. That means 147 is divisible by 3. So let's go. 147 divided by 3 is 49. 3 times 49. Does 49 seem familiar to you? That sounds like a perfect square to me. It's made up of 7 times 7. Once you have two of the same numbers, you don't have to try to break those numbers down anymore. I have 2 7s. That means they're going to kind of join together to be 1 7 on the outside of the radical. And this 3 has no partner. Anytime there's anything left over without a partner, it goes back under the radical symbol. And you can always double check with your calculator. All right, let's try number 8, 175. The 5 on the end makes me realize it's going to be divisible by 5. 5 times something is 175. So I'm going to say 175 divided by 5 is 35. Okay. 5 will not break down any further, so we're just going to hold on to that for right now. 35, I can do 5 times 7. And I rewrote 35, so I'm going to just cross it off. And now 5 and 7 will not break it down any further. I do have this pair of 5s. Okay, so that means a 5 is going to come to the outside. It's allowed to come out. The 7 has no pair. Anytime there's a leftover, it goes back under the radical symbol. So 5 root 7. All right, 2 more examples, and then we will talk about this when you come to the live teams meeting. 48, there's a bunch of ways to make 48. Right off the top of my head, I came up with 6 times 8. So I rewrote 48 as 6 times 8. 6 will break down further, 2 times 3. 8 will break down as 2 times 4. 2, 3, and 2 are all primes, but 4 will break down one more time as 2 times 2. All right, so now look at your pairs. I have one pair here, which means a 2 will come out. I have another pair right here, which means another 2 will come out. And I have this little 3 guy right there. He has no partner, so he's left over, so he has to go back under the radical symbol. 2 times 2 is 4, and then I have square root of 3. So we're just rewriting these in simplest radical form. One last one, pause the video, try it, and then check your work to see how you did. All right, let's see how you did. 54, it's even, so I know 2 will go into it. 2 will go in there 27 times. All right, 2 will not break down. 27 is 3 times 9. 3 will not break down any further, but 9 can be broken down to 3 times 3. Okay, now look for your pairs. I have a pair of 3s right here, which means one comes on the outside of the radical. Then I've got this 3 with no pair, which means he's got to go inside. But I also have a 2 with no pair. Well, what did we do when we had more than one thing that was brought out on the front? Like right there, we multiplied them together. So guess what we're going to do even on the inside? We're going to multiply them together. So I have a 3 on the outside and a square root of 6. All right, see you in class.
Yeah.